If you need full data access, that is the ability in your website to be able to work with and modify data, you need to use a data adapter, that is the SQL data adapter or the OLADB data adapter or any other data adapter, because the data adapter represents a set of data commands and a database connection, sort of wraps up the command and the connection object. It allows you to fill a data set or data table object using the fill method of the data adapter. It also allows you to update data using the update method of the data adapter. In this section, we'll only look at filling the data table or the data set. In a later section, you'll spend more time looking at updating data. Now, we'll use the fill method to fill a data set or data table. And that data set or data table provides a local cache for disconnected data. All that data, if necessary, is marshaled around the web as XML. You can make changes in the cached data, completely disconnected from the data source. You'll then use the data adapter's update method to write changes from the cached data back to the data source. To get data into the dataset, you'll use one of the 4 command properties of the data adapter, the select command. The select command property of the data adapter, and remember, there is nothing called a data adapter. There's a SQL data adapter or an OLADB data adapter. I'm just using the word data adapter to refer to any of those. The select command property allows you to provide a command which indicates how you want to get data, the select command. There's also a delete command, an insert command, and an update command property of the data adapter object, which allows you to specify what you want to do when you ask it to delete data, insert data, or update data. Those can be stored procedures. They can be raw SQL statements. Each property contains a command object. Now, you don't have to specify delete, insert, and update if your only goal is to retrieve data, but you do have to always supply the select command property. The data adapter uses those 4 command objects for selecting, updating, and so on. Everything you ever need to do with data is really summarized in those 4 properties. You can call the update method to perform updates against the original data. And there is more on that later on. For now, we're just going to be filling the data using the select command, which will fill a data set or a data table. I keep saying that because a data set can contain multiple data tables, or if you just need one data table, you can just fill one data table without encapsulating it inside a data set. That data set represents a disconnected model. That is, it has no knowledge of its data source. It does provide array-like indexing into the rows of tables. It also supports data binding. Both the data table and the data set can be bound to things like grids and lists. And it connects to a data source via a data adapter. Connects is a very incorrect word here. It actually gets its data from the data source using a data adapter. So here are the steps to filling a data set. You first create the data adapter, providing command and connection information either in the constructor for the data adapter or later. Normally, like I said, you pass this in the constructor. You can optionally set or retrieve the select command property explicitly if you want, and you can change it once you've created that data adapter. Then you call the fill method of that data adapter, passing in the reference to the data set or the data table object that you want to fill. If you're filling a data set, each time you call the fill method, you're really just filling a single data table, creating a new data table within the data set. And if you're going to have multiple data tables, you probably ought to specify a name for the data table. It's like when you have kids. If you don't bother giving them names, the best you can do is say, kid number 1, go brush your teeth. Kid number 2, time to set the table. If you actually give them names, you can say, Norma, go brush your teeth, or Emily, clear the table or set the table, whatever. You have to give names if you're going to have multiple data tables within the data set so you can refer to them later by name. This is important to note. The fill method uses the select command property of the data adapter, which is set sometime before you call the fill method. You can do it in the constructor of the data adapter or after you've built the data adapter. Either way, if you haven't set the select command property, the fill method will fail. If you want, and our example does this, you can iterate through the data row objects to view the contents of the new data table. That's what we'll do. You could also bind the data table or the data set to some object that displays data. But for this demo, we'll iterate manually through the rows to see what's in that data table we just created. I've loaded the default page again, and this time I'm going to use an OLEDB data source just to prove that I can, and I'll load up a data set with data in a data table and display that data in two different ways. Here I have a list containing the product name field from my table, and here I have a grid view control containing all the data from my data table. Let's see how that works. I'll load up the data set from OLEDB page and look at its code. You can see that the data set from OLEDB demo procedure starts by creating a SQL string which defines what data we'd like to retrieve. In this case, selecting all the columns from products where the category ID is 1. We have the try block here, which again displays an error message on the page should something go wrong. And up here, we start by having a using block to create our OLEDB data adapter. We pass in the SQL string as a parameter, which means that we don't have to actually generate a command object ourselves. The data adapter will do that for us. In addition, we pass in the connection string from our web.config file. Again, we don't have to create a connection object. The data adapter will do that for us. Next, we create the new dataset instance. Now you have to actually instantiate this because if you didn't, here when you call the fill method, you'd be passing in a null reference and it couldn't fill it with data. So you must instantiate the dataset before you call the fill method. Here we call the adapter.fill method, passing in the data set to be filled and the name you want to use for the data table that method creates. Now you don't have to specify a name. One of the overloads allows you to just pass the data set or a data table. But if you don't pass the data table name, you won't have a name. Actually, it'll be inferred from the SQL string, but you won't know what it is. It would be like not giving your kids names, and then if you have to refer to them, you have to refer to them by number. Kid 0, go pick up your room. Kid number 1, brush your teeth. Be way easier if you could call them by name. Nora, brush your teeth, or Emily, pick up your room, or something. So it's easier if you give these data tables names. And here I'm naming this table product info just to prove a point that it can be anything you want, not just products. Now the fill method has filled in the data in that data set. Now it's important to note that when it does this, it generates a command object and a connection object for you and uses those items. Down here, we filled in the data and we can loop through that data. For each data row in the rows property of the table named product info in the table's collection of the data set. Now, if we'd filled the data adapter and used it to fill a data table, we could just say for each data row dr in my data table, because that would be what we were referring to in our code. In this case, we need to get to the particular data table we want to work with. Next, we want to pull out the product name field from each row and add it to our list. Now, we could also set the data source of our grid to be that data set. Now, even though a data set could contain multiple tables, setting the data source in ASP.NET to a data set will retrieve the 0th data table and use it as the source for the grid. Don't forget to call the data bind method, which tells the grid that it's time now to go out and get the data and redisplay its contents. We could also use data binding with the list box control. In that case, we need to set the data text field property to be the name of the field that contains the text of the list. We would set the data value field to contain the name of the field that contains the value for each item. We set the data source of the list box to be the table that contains our data, and then finally call the data bind method to bind the list and the list box. Now, one thing to note, the fill method of the data adapter preserves the state of the connection it's given. Now, in this case, you gave it a connection string, which means you effectively gave it a closed connection. After this line of code, well, to do this line of code, the adapter has to open the connection, but it immediately closes it again. If you had handed it here a real connection object, dimension something, that is, create something as a connection object, here, if it was closed when you got it, it would be closed after the call to fill. If it was open before you passed it in here, it would be open after the call to adapter.fill. The point is, the data adapter.fill method preserves the state of the connection object it's given. If it creates the connection object, it opens and closes it. If you hand it an open connection, it remains open afterwards. If you hand it a closed connection object, it closes it after it gets the data. Once you've filled a data table with data, and you always fill data tables, you don't fill data sets, they just contain data tables. But once you get data into that data table, you have rows and columns to work with. Rows actually contain the data. That is, there's a rows property of a data table object, which is a collection of data row objects. Columns contain the metadata about each column. That is, there is a columns property that returns a collection of data column objects, and each of those has information about the schema of that column. You can access and manipulate data in a data table's rows using a data row object. So horizontal access to data uses a data row object. And you can access a data row object within the rows collection by index if you want. So you can go to row 15, or you can enumerate through them one at a time from top to bottom. You can iterate through all the rows using a for each loop. You can also use the new row method of the rows collection. You've seen this already, to add a new row to the set of rows. The new row method returns a data row object. All you have to do is fill in the columns in that row and then call the add method of the rows collection to add the new row to the end of the list of rows. Now, unlike other data structures you may have used, the data table separates data from metadata in two separate collections. If you contrast that with ADO record sets, which stored the schema information with every column and every row. A field object of an ADO record set, way back when, exposes everything, including the data and the metadata, like column names and type. Why do you want to carry this around with every row? There's no reason to do that. Instead, a data column object in ADO.NET exposes the rich metadata about the particular column from a particular table. It contains information about the data type, the max size, and so on. We have an example that retrieves that information and displays it on a page for a specific data table. Our last example retrieved data from an OLEDB data source. This time we'll use similar code to retrieve data from a SQL client data source, but this time we'll look at the data in the columns rather than in the rows. Maybe both, actually. So here's our page. Here we have a list of columns and their data types coming from our resulting data table. You can see the name of each column and its type. Here we have the data itself displayed within a grid. And this probably gives you information about how this grid view control knows how to display the contents, because it too uses this information to know how to display everything it displays here. It knows that this is an int32. It knows that this is a string because it retrieved that information from the source of its data. Well, let's go look at the code to see how we got this list box filled in. It's obvious how we got this filled in. You've seen that code already. But let's see how this itself gets filled in. I'll look at the data set from SQL Client Pages code, and here we have very similar SQL string, what you saw before, the same using block for the data adapter, the same call to adapter.fill to fill the data set. Here's the difference. Rather than looping through each row in the rows collection, we're iterating through each data column in the columns collection. For each data column object, we can retrieve any number of different bits of information about the column. All I'm retrieving is the column name and the data type. And it will format those using string.format using this template to display them, add each one in turn to my list box. Once I've iterated through all the columns and added each of them to my list box, again, we set the data source of the grid to be that data set. What I didn't mention earlier, by the way, is that you generally don't want to set the data source of a grid to be a data set that contains more than one data table. It's not explicit. You're better off explicitly indicating which data table you want to use, either by specifying an index or the string that represents that data table, its name. Either way, you get the same results because the grid view control, when you set its data source, knows to retrieve the 0th data table from the data set. It's just not explicit. This is explicit. Either way, it works though. So you've seen now how you can iterate through each column in the columns collection to retrieve information about the column name, the column type, and actually, you can see here, there's a lot more information that's provided there as well. So now you've seen the basics of retrieving data using the data adapter and the command and the connection objects and also retrieving schema information. But how do you decide which provider to use? Are they equivalent? Remember, ADO.NET uses a provider technology for connecting to the data source, executing commands, and returning the results. And the results can be processed directly, placed into an ADO.NET data set or data table, or sent between the tiers of your application. That's what ADO.NET and its providers do for you. But most importantly, those data providers are designed to be lightweight, that is, not get in your way and add extra overhead to your application. They should be efficient. They should be unobtrusive. Like I said, not cause extra weight in the application. And they should be able to increase their performance while not impacting your functionality. So the goal is that they help you, not hurt you. So you have to decide which one is the best for any given situation. For example, the SQL Server data provider, that's the SQL Client namespace, that communicates directly with SQL Server 7.0 or later. It doesn't use OLEDB, it doesn't use ODBC, it's using native SQL Server APIs. It's a managed provider, which means all its code is written using the .NET framework from front to back. Any place you use the SQL Client namespace, you're using managed code. You want to use this namespace if you're, for example, building a middle-tier component that uses SQL Server 7.0 or higher, or if you're building a single-tier application using the Microsoft Desktop Engine MSDE, which was the free version of SQL Server before SQL Server 2005, SQL Express, Microsoft SQL Server 7 or higher, or any other flavor of SQL Server that comes out. That's what you use for that sort of application. If you're using SQL Server 6.5 or earlier, first of all, it's time to move up. It's been a long time. But in any case, if you're forced to use an old version of SQL Server, you're going to have to use the OLEDB namespace because the SQL Client namespace doesn't support that ancient version of SQL Server. you'll use the OLEDB namespace, which provides native OLEDB through COM interop. And in that case, you're using unmanaged code. The underlying provider, that is the part that actually talks to the data, wasn't written in .NET, and therefore it's unmanaged code, and you have to use COM interop to communicate between your managed code and the unmanaged provider. You must use an OLEDB provider if you're using an older version of SQL Server. In that case, you're using the SQL OLEDB provider. MSDA ORA, that's the Microsoft Oracle provider. Or the Microsoft Jet provider, microsoft.jet.oledb.4.0. And you'll want to use the OLEDB namespace if you're building a middle-tier application using an old version of SQL Server, or if you're building a single-tier application using Jet. Notice that Microsoft really doesn't recommend creating middle-tier components that use Jet. It just wasn't written for that sort of thing. I know people do it. I know you may be doing it. But Microsoft doesn't recommend that because Jet wasn't built. That is, an Access database wasn't meant for middle-tier components in a distributed application. Now there's also the ODBC data provider, and this provides native access to data retrieved using ODBC drivers. It was written to work with all ODBC drivers, but it's only tested with a subset. Microsoft can't possibly test it with Joe's ODBC driver or Mary's ODBC driver. Those people have created ODBC drivers for all sorts of data, and Microsoft can't support them all. If you use ODBC, you'll be using the system.data.odbc namespace to do your work. Now, you might want to write code that supports multiple namespaces with a single set of code, and you can do it. Do you have to write special case code for each? Well, I gave it away. Actually, you can write generic code, but you'll often have to write some special case code. You can take advantage of ADO.NET provider factories. You supply a provider name, and the system.data.common.db provider factory class returns a strongly typed connection object, and from that, you can get at your data. So all you need to do is write one set of code using objects from the system.data.common namespace, given a provider name as a string, and from then on, you're writing common code. It's important to note that both SQL connection and OLEDB connection, and I'm assuming all the other connection objects in the world, inherit from system.data.common.db connection. And because of that, you can supply the provider name, the connection string, and the command text, and with just those 3 bits of text, generate a SQL connection, an OLEDB connection, or any other strongly typed connection. Once you've done that, all the rest of the work is done generically. I have a simple example that shows off using code from the system.data.common namespace to be able to work with either a SQL Server database or an Access database without rewriting the bulk of the code. To demonstrate provider factories, I'll click this link, which brings up a page which is going to run the same code twice, once using SQL Client, once using OLEDB. Here we filled this list box with data from a SQL Server database, and now I'll do the same thing, filling the data from an OLEDB database, an Access database. And although the demonstration doesn't seem to prove much, let's look at the code to see how it works. First of all, you'll notice that there's a read data procedure which takes in a string which represents the provider as a parameter. Down here are button click procedures call read data, passing in a string in each case, which is the name of the provider. Okay, well, what does read data do? Read data starts by creating a new DB provider factory object, which it gets by calling the DB provider factories object, that's actually a class, has a static getFactory method. You pass in the provider name, and it hands you back a factory that it can use then to create other objects. That's what a factory is. It creates things. In this case, our DB provider factory creates, well, connection objects. How do we do that? We call the factory.createConnection. Now that causes the DB provider factory to create a SQL client connection object because it knows that's what the provider was, or an OLEDB connection object if that's what the provider was. So CNN in this case is declared as DB connection, but it's actually a strongly typed connection. It's actually a SQL connection or an OLEDB connection depending on which provider string you pass in. We have the connection created. We don't have its connection string yet. We need to get it from our web.config based on the provider name. I'll go to this procedure, and you'll see how it works. In this case, you pass in the provider name. Now, I could have made this would also allow you to pass the connection string name, but in this case, I wanted to look it up by provider name. And the way this works is it loops through all of the connection string settings that it finds, and if the provider name property equals the provider name you've specified, we return that connection string back out. If we don't find a match, we don't, and we return basically a null value, and that's all. Back here, we get the connection string, and we then use that connection to create a command. You haven't seen the create command method before, but it creates a strongly typed command of the same provider as the connection. We have our strongly typed command. We set its command text. We open the connection, and we execute a reader to return back a strongly typed reader. It says DB data reader here, but it's not. It's a SQL client data reader or an OLEDB data reader. That's what we get back. Once we have the data reader, we just loop through all the items as you might have seen before. How does this code work? It gets a provider name, creates a factory, the factory creates the connection creates the command creates the data reader. At no point do you see any SQL client or OLEDB objects in this code. The code does its work by using the provider factory to give you or hand you a strongly typed connection, and from there you can generate all the other objects you need. This one block of code works both with OLEDB and with the SQL client namespace.